Okay, got the variscope hooked up. The leads are going out the door under the car. Positive is on the yellow, negative is on the black. We'll turn the key on, see what happens. And crank it. Okay, so this wire, I'm assuming, is a pull down because it's 0 volts, but when you plug in the module probably has, you know, a 5 volt signal that the computer pulls down the ground. So we don't, you know, this isn't a bad signal. I just wanted to see if the computer is sending out the pulse or if it's just pulling down the voltage that's coming out of the module. And since we don't have the module connected, we just have 0 volts on there. Okay, so no big deal. Can we verify wiring integrity? I guess we can plug in the module and back probe that wire just to be 100% and see what it looks like. But otherwise, this thing is bad. Alright, so I redid the wires, plugged the module back in. Now we're just back probing the yellow wire, and the negative of the scope is just on a body ground. Turn the key on. Key on. No beans there. Well, the module could still be bad. It's not putting out the correct wire that goes to the PCM, so there's no real other way to verify the computer control without feeding that wire some voltage. And if the module can't do it, you know, we could try a resistor box or something, but again, you have to be careful. If you send too much current down this wire or the wrong voltage, the computer really won't like that. So at this point, I think we're done. We're calling the fuel pump control module, and to make the car movable so it actually starts up and runs and I can pull into the shop, all we have to do, very easy, since we know we have a good power here, just jump that to the other blue wire and jump the ground to the orange wire right at that 5-pin connector. So basically two jumpers. I'll leave the yellow pin out and the car should start and run. Well, I drove the car in to the shop using the jumper method. Drove in fine. However, I did set some codes. The check engine light came on. We have ECM 720A mobilizer communication, 261A fuel pressure system signal too high, interesting, and ECM 2610 fuel pump signal too low. Huh. Curious, because how does the fuel pump module know? Is there a fuel pressure sensor? What? Reading off parameters, digital display, readiness codes, reading off control module, diagnostic trouble code information. Let's see, digital display. See what kind of data we can see here. Is there a fuel pressure data PID? Status value custom list. All right. Fuel pump relay status. Looking for fuel pressure. fuel pump duty cycle, fuel pressure, and like this. Alright, okay. Fuel pump duty cycle 84%, fuel pump relay off, fuel pressure, KPA. Can we change the units? Let's see here. I don't want to lose the information, but we might have to. Setup. Units. English. I want to read in PSI. I'm going to go back in. It's a little primitive. It kicks you out like that if you want to reset your units, but we'll get back in here. It's actually pretty quick. No way the snap-on would read a VIN. Tell you that right now. All you need to do is select your transmission. It's automatic. Would be cool if it was manual. And you hop right back into our engine. Control unit. Engine. ECM. Digital display. So remember, the all data description says a fuel pump module is not monitored, but apparently we can get some readings from somewhere. It's not happy with the fuel pressure. So fuel pump relay 1, 2, 3, 4, fuel pressure, fuel pump duty cycle, fuel temperature. Okay. Wow, it measures the fuel temperature. That's neat. So it's 42 psi right now. So there is a fuel tank, or I'm sorry, fuel rail pressure sensor on here somewhere. Kind of want to start it up without the module in place, and we can plug it back in and see what it says. You open the door, I don't want to stink up the garage. Alright, here we go. Start it up. You gotta be kidding me. The battery's dead? You gotta be kidding me. Ah. Alrighty, we got the NOCO hooked up here. The battery's in the trunk, but we can jump start it from here, I think. Oh, come on, give me a break. Stupid light's probably killing the battery. There we go. Let's back this sucker out. I know you don't like the high fuel pressure there, Volvo. I hope it's charging. We can double check the voltage. Back this out. Alright, turn on the scanner. Alright, charging system voltage is 14.5. I'm happy with that. We're just going to let it run for a bit. Alright, so we're at 80 psi. Fuel pump duty cycle is 6. Fuel pump relay is on. So it's trying to decrease the percent fuel pump duty cycle to decrease the fuel pressure, but it's at 80 psi, which is obviously too much. Anything else that we wanted to... Let's see, long-term fuel trim. Area 1. Okay, short-term, long-term. I need this. Okay. Let's see if it's trying to take fuel away here. So maybe it's smart. If it knows the PSI, it has a fuel map, so the fuel trims are actually not bad. Should run okay. But obviously it doesn't like it's trying to reduce the duty cycle of the fuel pump to reduce the pressure, and it can't. So everything checks out here so far. The only thing we're not 100% sure of is the pulse width modulated control wire from the computer to the fuel pump control module. You know, we couldn't really check the wiring integrity because the module wasn't sending out whatever 5-volt signal. So I want to tear the module apart and see if we can fix it. No parts required. Put a current meter on the battery. It's charging at 30 amps. I guess the battery's kind of discharged. Okay. And I felt this terminal. It feels quite warm. That's not good. It's a little crusty and rusty. I don't think it's all the way on there. So I'm gonna have to redo that connection there. By the way, how about this? Rear facing seats and wood trim panels only in a Volvo. I think that's pretty neat. You sit on here, put your feet in here. Cool. Alright, here it is on the bench. The Volvo PEM, fuel pump electronic module. Or as Volvo likes to call it, the polymer electrolyte membrane. Whatever it is, it's here. And we're going to tear it apart. Wouldn't it be epic if we could fix this thing? No parts required. I have my doubts, but it looks like it has all these clips and it should come apart. So I'm going to clean it off and we'll get to work. Alright guys, here's what we got. A bunch of sand. It's coming from the definitely water intrusion through that aluminum heat sink for sure. This side of the circuit board looks pretty good. I think the other side we might find something a little worse. Alright, let's get this circuit board out of here. Well, that screw snapped off. That's not good. Oh, the pick. The pick comes in handy for just about everything. Now, my question is, are those pins? Oh yeah. Yummy. Those pins are soldered, obviously, to the circuit board. So, let me dump all this junk out of here first. We'll take a look at what the board looks like underneath. Well, things look as crusty as they can possibly be. It looks like salt crystals or something. Wow. The circuit board itself, I mean, I guess a can of deoxit could clean it up, but who knows what electronic components got hurt when this mess shorted out. So, yeah, we'll get a new module. It's like 500 bucks. Keith said you have to program these. I'll have to talk to him. Not sure. I don't know if you just plug it in or not, but brilliant design on Volvo's part. Sits right on top of the fuel tank. All the moisture just collects in these fins, and this aluminum, huge aluminum heat sink just, man, can't take it. Corrodes from the inside out. Ridiculous. That's what it is. We'll order the new one up, and we'll be back with the repair, verification, and I know we have to program this thing in. We'll have to look at the procedure. Alright, just for kicks, I'm going to spray it with deoxit and plug it back in and see what happens. I want to see what that PWM signal looks like. on the yellow control wire, and then figure out, is this thing smart or is this thing kind of dumb? Is the computer actually talking to it, or is it just sending like a square wave for the duty cycle? So we'll let the Diagnostics do its magic. The circuit board itself, I would say, looks pretty good for considering that. So the only thing that really got messed up is the heatsink, but then that might have cooked the actual transistors, who knows. But when we unplugged it, we saw all those codes. Now maybe the car needs to be running for the computer to realize that, hey, you know, my control signal is low or whatever. Let's plug it in and see what it does. Alrighty, so put the module back in, kind of. It's just hanging out here. Make sure it's not shorted out, but it's plugged into the original connector. And I'm interested in is what the signal is on this yellow wire that goes to the module. So I decided to pierce it and make sure we have a good connection instead of back probing it down there. And let's fire up the scanner, see if this thing talks, see what the actual signal is. Well, we've got a windstorm, power went out, but that does not stop us from making videos. Everything's on battery power, so that's the way it is. Let's hook up our scope, hook up our scanner. 0 psi. Fuel pump relay is off. So I'm going to crank it, see what happens. Cool. So obviously we did not have fuel pressure. And let's go back and look. Zoom out. Oh, are you kidding me? Oh, here we go. Let's zoom in on that. Okay, so we need to get a bigger time base, obviously. Let's go to 2 milliseconds. Try again. Oh, the battery's dying. Stop. Crap. Scanner shut off. Oh my gosh, this battery's spanked. Ah! Come on, Snap-on. There's no buffer. I don't have any cranks left. 2 milliseconds is too short. You can only change it when you're recording. I think 100 or 200 milliseconds. Oh, that's the whole screen. Isn't it supposed to be per division? That's when you need a pico. Alright, got the no-go hooked up. Got the scope on a 50 millisecond per screen setting. And that means your total buffer is 13 seconds. That's how you can tell that number right there. So, let's see what happens when we crank it. Off, pause, zoom, Got it. So there we go. That's our pulse. So now the question is it coming from the computer or is it coming from the module being pulled down by the computer? We can unplug the module and repeat this test, and that will at least tell us what the how it works. So right now it looks like it's a dumb module that we don't have to program, which would be really awesome. The only thing the computer does is vary this pulse width, and the module spins the pump accordingly. So we're going to save this file and then repeat it with the module unplugged. Alright, so during that crank, system pass, no fault codes detected, amazing, even though we had no fuel pressure. So this computer's kind of dumb, I guess. Let's unplug the module and repeat this test and see if our wire shows any voltage at all. Alright, I unplugged the module. We still have no codes. Let's roll the scope. Roll the scope. Crank it. Nothing. Read codes. System passed, no codes detected. So we saw nothing on the scope. So indeed, the module is sending out a 12 volt constant, voltage on the little yellow wire going to the engine control module, and then the engine control module is pulsing it to ground. So the duty cycle is the percent of the square wave that's pulled to ground. So 84% would be, 84% of the time it's low. It's a pull down design by the computer. So that's it. Everything checks out. We're getting a new module for this thing. Fortunately, I can't fix the old one. It's toast. And good thing is we do not have to program anything here. Plug and play.